Let us consider the structure for a state pattern. See, here we consider the context class, state class and concrete state A and state B. Suppose if a client sends a request to a context, this context receives the request from the client and it's hand over to the state. It handles to the state, and this state represents this state performs the operations when the request comes from the client, and it results the operation based on the state that has internally. Suppose if it has a state of a concrete state A, it has an internal state and it performs the operation of concrete state A. Suppose it has a state of a B, operation B in a state, so it will performs the operation of B based on the state that has internally. Based on the context of object state, the behavior will be different. So, this is the structure for the state pattern, and based on this, let us see the participants of a state pattern structure. So, we have three participants. The first one is context, and the next one is state, and the next one is concrete state. So, these contexts will become as a TCP connection, that which we have seen in our example of motivation. So, this context will become as a TCP connection in our example, and it defines the interface of interest to clients, and it maintains an instance of a concrete state subclasses that defines the current state. And the next one is state. This state defines the TCP state, which we have seen our previous example, TCP state. It defines an interface for encapsulating the behavior associated with a particular state of the context, And our next pattern is concrete state. That is nothing but a concrete state subclasses, that which we say as a TCP established, TCP illusion and TCP closed in our previous example. In this, each subclass implements a behavior associated with a state of the context. So, these are the participants that which we have involved in our structure of a state pattern. Coming to the consequences of our state pattern, and the first one is it localizes the state specific behavior and partitions behavior for different states. That means the state pattern pulls all behavior associated with a particular state into the one object, because all state specific code lives in a state subclass, and a new state and transitions can be added easily by defining new subclasses. And the next one is it makes state transitions explicit. When an object defines its current state slowly in terms of internal data values, its state transitions have no explicit representations. They show only up as a assignments to some variables and introducing separate objects for different states. That makes the transitions more explicit. And also, state objects can protect the context from inconsistent internal states, because state transitions are atomic from the context perspective. They happen by rebinding one variable, and the next one is state objects can be shared. That means if state objects have no instance variable, that is the state they represent is encoded entirely in their type, then context can share a state object. When states are shared in this way, they are essentially flyweight with non-intrinsic state, only on behavior. And coming to our next template, collaboration. Coming to the collaboration, here we see the explanation about collaboration. In this context, delegates state specific requests to the current concrete state object, and a context may pass itself as an argument to the state object handling the request. This lets the state object access the context if necessary. And the context is the primary interface for client. Client can configure a context with the state object. Once a context is configured, its clients doesn't have to deal with the state objects directly. Either context or the context state subclasses can decide which state succeeds another and under what circumstance. And coming to the implementation of our state pattern, for implementing the state pattern raises a number of implementation issues. In that, some of them are: who defines the state transitions? That means the state pattern doesn't specify which participant defines the criteria for state transaction. If the criteria are fixed, then they can be implemented entirely in the context. It is generally more flexible and appropriate. So, this is one of implementation issue, and the next one is a table based alternative. And the next one is and the main advantage of this table based alternative is it is either regularity and you can change the transitions criteria by modifying the data instead of changing programming code. And based on that, we have some of the disadvantages, that are table lookup is an often less efficient than a function call, and putting transition logic into a uniform tabular format makes the transition criteria less explicit and therefore harder to understand, and also it is usually difficult to add actions to a company that state transitions. And the table driven approach captures the state and their transitions, but it must be argued to perform arbitrary computations each transitions. So, we can say these are some of the disadvantages along with the advantage of this table based alternatives. And coming to the next one, creating and destroying the state objects. A common implementation trade off worth considering is whether to create a state object only when they are needed and destroy them thereafter versus, and the next one is creating them ahead of time and never destroying them. And coming to next one, using dynamic inheritance. Changing the behavior for a particular request could be accomplished by changing the object's class at a runtime, but this is not possible in most object oriented programming languages. That means exceptions include self and other delegation based languages that provides such a mechanism and hence supports the state pattern directly. And objects in a self can delegate operations to other object to achieve a form of dynamic inheritance. Changing the delegation target at runtime effectively changes the inheritance structure. This mechanism lets objects change their behavior and amount to change their class. So, these are some of the implementation issues that which we can say under our state pattern. And coming to our last template is nothing but a related pattern. In this we can say that flyweight will become as a related pattern to our state pattern, because the flyweight pattern explains when and how state objects can be stayed. State objects are often singletons. So, this is the explanation about our state pattern. So, in this we have discussed about introduction of a state pattern, an example of an ATM which is belongs to best example for the state pattern, and the next one is intent, also known as motivation, applicability, structure, participants, collaboration, consequences, implementations and related patterns of our state pattern. So, this is about the state pattern under the behavior pattern of our unit 5th, first pattern of our unit 5th.